Hi and welcome to 3D Print Tech Design. My name is Anton Monson and today we are reviewing the Thunk3D Juwelry 3D scanner. I can't pronounce that. Juwelry. But first, let me explain what's so special about this scanner. This is a scanner made for really tiny, high detail, high accuracy objects. As you can see, I can barely fit a 3D bench in it. It's made for scanning everything from rings, jewelry, paper clips, figurines, whatever you want to scan, but on a smaller volume. So in my review, I'll check out everything from how the jewelry scans, how you can scan tiny objects, how you can use this to enhance your production, like analyzing 3D prints and analyzing machined parts to see how well they are made. Because this scanner has some incredible specs, and I think we should start with those. So this scanner and most other 3D scanners work by having two cameras and a projector. Well, the projector will project a light on the object, a really tiny pattern, and two cameras will see that pattern and create a depth image. If you want to know more about how that works, I have an article written down below, or I will have it, and I'm gonna link to that if you want to read up on exactly how a 3D scanner works. But basically it creates a depth image from one side of the object, and what's really unique about this machine is that it rotates the object for you. So it can rotate the object in two axes, which really helps to cover the whole area of the scan, minimizing the amount of matching and you having to do work around it. So it's a really easy scanner, like usability wise, at least on the hardware. But if we start to talk a little bit about the software, I'm going to show you all the steps on this scanner. You can check out the timeline down below if you want to jump ahead a little bit. But we're going to start off with the software. So as of 2021, January, when I'm recording this, the software is not really super good. It has all the features that you need, but they are not really well explained, and the flow of the scanning can be quite difficult to understand. There aren't really any good guides. You get this paper and there's a PDF with like the flow, but it's not really good enough, so I'm going to show you the complete flow. So the first thing you do, of course, when you start up the software is to turn on the power button. When you then actually turn on the software, the scanner will home itself, so it will zero out any access. In the software, you see we have a full menu up here. It's very confusing, or it could be. On the left, you have a preview of one of the cameras. You can see my fingers there. We have down here, we have exposure. So this is the camera exposure. We will use that a lot. You can see if I change that, everything will get brighter and everything that's red is overexposed. On the left side, we have a height of our cutout plane. We'll explain that a bit later on. On top, you have new project, you have calibrate, and you have settings. So in settings, these are basically the mesh settings. So not much to do here. We can change all of these as soon as we do anything. Lastly, you have, of course, help. And yeah, you can find some information. That doesn't really say a lot. Okay, so the first thing you want to do when you start up the software, and basically whenever you want to scan, I would recommend that you always do a calibration. So you click on that and you have to put your calibration plate. I'm guessing mine is 5mm, pretty sure it is. And then you put in your calibration plate inside the machine. It has these magnets, so it will kind of only lock into one position, like so. So right now the projector is not lit, that's why we're not really seeing this. But as soon as we click apply on calibration, the scanner will look at these patterns. You can see these crosses, so it detects every motion, which means that it's tracking its motors, it's verifying that the cameras are looking and focusing on the same points, and that basically all math is correct. And then we're done. So we can see our accuracy value, 0.01 millimeters. It's even more extreme than that. So now to do a scan, you will click on new project. You can name your part, but basically you want to save your file somewhere good. So we can also click here. We have target, 1C or whole and parts. For whole and parts, you can only do the multi. So it's like several parts but in the same STL, I suppose. So if we go with 1C, we can then choose scan mode, so either doing one small, one STL file, one object, or the multi-object that I'll show you guys later with, for example, many rings. Then we can choose HD scan or fast scan. Basically, this is how much data you're getting. So maybe you want to do a fast scan to see that you can reach all the areas, but I would always go for a HD scan. I think that's much better. Then when we're done with that, before you click continue, we'll have to name it to something. Let's go with test. So after removing the calibration plate, you of course have to secure your part before we can click continue. So basically get your part in and make sure that it's secured correctly. So when you're happy with that, you have to check the exposure. As you can see here, it's very sensitive and very good for light objects. As soon as you want to start scanning darker, you have to adjust for the exposure on the left side here. The thing is that the darker you scan, the more noise you'll get from the camera. So try to always use something bright or scan something bright. You can always use a contrast spray like this AU sub spray. I have those linked down below as well, but this scanner is so accurate that you can actually detect the spray. So if you have some super exact items, if you spray this spray on, you're going to get a tiny like filler. So if you have tiny details and want to scan them, the spray will actually work as a filler, which is not what you want to. So when you then click scan, the scanner will do a pre-programmed path. So it's going to rotate in 2 axes, trying to figure out all the best positions to scan and to get as much data as possible. Usually it does a really good job of this, but sometimes you can kind of feel like there are areas where you want to be able to fill a little bit extra. And this scanner also fills any holes, so the more you can fill in yourself, the better it's going to be in the later stages. But what's really cool with this scanner compared to a lot different scanners is that you can actually click on this button that tells you to add a scan, and when you do that, it will actually lock the camera around your 3D object. So when we are looking inside the software, figuring out what angle we want to see more from, the software will actually track that back to the camera movement. So if I click add scan from this camera angle, it will move the object to the corresponding angle for the cameras and the object in real world and actually scan from that angle. This means that it's super easy for you to figure out what areas are missing data and then zoom in on those and add a scan. And you can keep adding scans until you're happy. And then you finish off, it will register a bit, doing some thinking behind the scenes to kind of figure out exactly all the images. What you want to do next is really important, and that is to remove anything that you don't want. So you're just going to use a lasso tool to remove the mesh. Because then you can, if you want to, you can add a different scan. So for example, turning the object around, that really works well if you have something unique and trackable, not something that's symmetrical. Like a ring can be very difficult to turn around. You can see on one of these rings, I've added a little bit of clay to make sure that I know which side is which. So if you want to turn your model around, all you have to do is scan as regular, check out your model, add some scans if you need to, and remove any mesh. Then you have to turn the physical ring around, of course. It can be quite tricky, especially with coated metals. You can see that the ring loses its powder a bit. Then you do another scan, you just click continue scan. It's all sped up here to save some time. And of course, remove any unwanted mesh that you don't want to. And then in this phase, you will have 2 different scans, and then you match them up with different points. You can see I'm clicking out orange points, yellow points, and there should be a green point as well. But basically, then you align these points, and the computer will help you find, like you can see here, 3 points is all you need, and they are aligned. So when you're happy with all that and you have cleaned up the model, it's time to mesh the model. So all these dots that we're looking at, that's only a point cloud. It's so much data that we have to make a mesh out of it. Or we don't have to, but we can make a mesh out of it. So the meshing tool is kind of simple. You have some settings. To be honest, I haven't really seen a lot of difference depending on what settings we're using. But yeah, keep as much detail as possible, because when you export this model, you can do all the final retouch and smoothing and all that. And speaking of export, when you mesh it, it will actually save the STL file. So you don't have to save a lot of things, it does that for you. And what's really good, especially if something would crash, which I've had one time for like 40 scans, so it's not often that it crashes, but it had happened. What's really good about that is if you're really into the 3D scanning and you have all the softwares to like take out individual points clouds and do your own point cloud alignment. This scanner will actually record each image and allow you to see it. Even if the software crashes, up to that point during the scanning, you will have data. So you can always kind of recover that if you want to. Okay, so to test this scanner, I really wanted to reach out to local jewelries. I tried, but it was really difficult, especially during COVID, to kind of get someone to go over here with some designs. Because this scanner is made for jewelry parts, even though it works really great for mechanical parts too. It's kind of designed to be simple, easy to use for designers to record their jewelry pieces, to make copies or make changes. And what I really wanted to test was to take like these pre-made or pre-cast models. So we're talking handmade jewelry designed, made by a very skilled artist. Because these designs are very difficult to reproduce. Maybe if you have some failure during casting, maybe you want to do larger scale production with 3D printing, maybe you want to do something else with the design, or even just record it to have it saved. A 3D model would be so much better than a like photo of the design. I wanted to try this scanner on those kind of parts, but unfortunately I couldn't get hold of a designer that would work with me. So that kind of material is kind of matte, kind of wax-like. I don't have anything that represents it perfectly, but I do have these Warhammer 40K plastic parts that I think are fairly similar to some of the harder wax models. So we are going to test it with those, of course, but also with real rings. Something that works and is already made. So for example, if you want to make copies of this ring, how well will the scanner work? But we're not only going to test that, we're going to do a lot more of the mechanic parts later on. But I really wanted to show you how this ring capture multi-scan kind of works. So let's check out that first. So the first thing you want to do is, of course, to kind of get your parts on this multi-scanning plate. By the way, all of these plates are interchangeable, so they position into the scanner really well. So you put a lot of objects here. You then select a new product, you do the multi-scan, and you just look at the exposure, make sure it kind of looks well. As you can see, I sprayed these models. Then basically all you have to do is allow the scanner to do its normal procedure, its normal path. You can then add scans from different angles if you want to reach more difficult areas. And in the next step, it's really interesting because you have to clean out each model, so you have to separate them yourself, especially if you accidentally scan some of the plates. Then the machine will treat them as separate STL files. You can see they're all numbered, and it's really cool because you get separate STL files for each ring that you put in. I guess this is fairly good for jewelry design, especially if you have a lot of different concept designs, you want to kind of record them all. I think it might be even better for like dental scans. So if you have different setup of teeth, I guess that would work really well as well. Because for the rings, you get better precision and you get more opportunities to do dual scans if you do it in a single scan mode. I think it's much easier to do single scan, but you have the multi-scan if you want to use it. All right, so I've talked about the jewelry scanning. Let's see some examples. Everything you're going to see is before export, before any type of finishing. So the surface in the mesh, that's what you're gonna get. But yeah, as you can see, the result of scanning some of these rings, even this knot ring that is super difficult to reach all the areas, the scanner is doing an amazing job of getting all those details from different angles. And not to mention the paper clips. I mean, how is that even possible? We can measure the thickness of the wire in the paper clip. That's still amazes me. It's really cool that we can see those details. And again, with the Warhammer figurines, it's super detailed. It's something that I'm very happy to. And if you want to subscribe, there's gonna be a video in maybe 1 week or 2 weeks where I'm using this scanner to scan a complete selection of Warhammer figurines, and I think that's gonna be super cool to have those digitalized so I can print new ones when I want to and even post them and all that. Okay, so enough about that. Let's talk about the post-processing, because as I mentioned, some of these mesh files are, I mean, they're good, but they're not perfect. So looking at this ring, for example, it's not a perfect scan. We have some noise. The spray didn't make a perfect job. So if we import this into Autodesk Mesh Mixer, which is a free program. So you can see here we have actually 1.1 million vertices and 2 million triangles. So this is a lot of mesh data. But you see this part here, we kind of want to smoothen that out, among other things. So we can use some tools in here, brush tools. We got bubble smooth, shrink smooth, robust smooth. So I'm just gonna try a few different here. Usually you need to increase the strength and maybe even the size, but you can see we're starting to sculpt here a little bit. This is something that you can spend forever on, so it's totally up to you how much you want to post-process, but if you were to make a proper copy, you would probably have to spend some time just smoothing things out. But it does take a while. But you can also use like some precision pencils and brushes to refine details. You can see in here, we're refining some details, making the joint between the two strings much better. You can see here we have some overfill, where the scanner filled a lot of holes. So by reducing that a bit, we can make the transition look a bit better. But yeah, you can actually do so much more. So if you want to modify your item, I'm not a jewelry designer, but you can see I'm trying to make some extra sculpting flat thing here. But yeah, again, this is a profession by itself, but you might want to check it out. And you can use Mesh Mixer because it's free and it's very easy to get started with. But there's plenty of other software. Talking about post-processing, that's a really good transition to what the heck are you going to do with these models? Why are you scanning jewelry models? I kind of mentioned it, but I see a great potential for jewelry designers and other designers for that matter to actually be able to record what they're doing. Their handcrafted work can be enhanced in the computer, or it can be digitally restored, or it can be just digitally archived in a 3D file instead of you know, doing the design, casting it, and well, then you don't have anything left. So for anyone buying a scanner like this to scan jewelry, I would say that you have to expect to do some post-processing by sculpting, smoothing out, or just refurbishing some of the details that you can't reach before you, for example, print it or something like that. Let me know if you're interested in like a full guide about how to sculpt, because I can probably show that as well. So just mention that below. The software, Autodesk and ZBrush and all that are linked down below if you want to check that out as well. Since this scanner is so freaking accurate and detailed, what other kinds of applications can we use it for? So I'm going to do some scanning of mechanical parts, prints that I have, and a bunch of random items. But I'm also introducing a concept here on 3D Print Tech Design, which is basically scanning controlled parts. So I have a different parts, another video about that, but one of those parts is a really tiny valve, and I thought that maybe we can scan that with this machine, and actually it went really well. I also went ahead and bought a 123 block, a really highly machined, high accuracy part. Unfortunately, it's actually too big and it's actually too heavy to be able to scan with this scanner. So we'll have to use other types of measuring parts. And to be honest, I can't really verify the millimeter accuracy, but it seems like it's handling it very well. So let me show you some scanning of different parts and let's talk about the results. It's so cool to be able to scan a Warhammer weapon. It's so tiny, it's incredible. And this part, for example, we'll use it a little bit later, but it's super precise and you get really sharp corners. Here you can see the weapon. I mean, look at that mesh. That is super tiny, and the paperclip is also crazy. This calibration part came out really well. We'll talk more about that in a second. But what I find really interesting is this 3D Benchy. This is not sprayed, so this is uncoated with some reflecting material, really difficult to scan. But we can see, like, we can't really see the text underneath, it's not visible on the print either. But we can see like all the layer shifts, the layer lines ghosting. We can actually detect each 0.2mm layer. So you can see here all those layers. And yeah, we can see some on the top as well. And I think it's super precise. Look at that, you can even see the depth. You could probably measure all this if you want to. Yeah, look at those layer lines. So when scanning this test part, for example, it's really interesting to see how we can actually reach in very far into these areas, because the cameras are pretty far away from the object, so they can look kind of far into different holes. And having the add scan mode, where I aligned my camera view and trying to reach extra areas, this scan went really, really well. I'm kind of amazed on how well we could reach into all the different holes. It's kind of interesting because this scanner has such a high precision. These two products that I designed and had manufactured, this is the prototype state of the products. So I actually had this machined. Well, this is CNC machined, and this one is 3D printed in metal, in Titan. As some of you know, metal printing can be kind of difficult. Usually there's a lot of warping in that. I'm scanning those parts to be able to verify how well they are produced, because in my CAD file everything is perfect, but how did they actually manufacture it? So using this free Gomming spec software, I can load up my original CAD file, so the perfect CAD model, so to say, and then we can also import our mesh. You can see I have already pre-aligned them. You can do that in this software as well. So if we then run a inspection deviation analysis, so surface comparison on actual part, I think that's what it's called, we can use some standard settings, 2mm maximum distance for like comparing. We get this really cool model. So this is a colored deviation, so red and super blue. Those are two opposite deviations basically. So you can see around green is 0, and then we have up to 0.2 on the yellow parts. We can also point out some particular spots if we're interested to check those out. You can see the deviation is here. It's actually quite a lot for being 3D printed. So looking at the CNC version, doing the same with the mesh, also scanned of course. In this CAD analysis, it's very interesting because you can see directly that it's using the same settings, it looks much more green and yellow, but even the scale is different. So at the yellow stages, we're only talking 0.05mm off. So it's like way more precise than the 3D printer part. Even at the bad areas, the red area, it's only like 0.1mm. Yeah, with this software you can do some really cool like color graphs and PDFs with reports on how things work. And yeah, it's something that I find really cool to be able to do with this scanner. So conclusion time. Again, Thunk3D delivers really good 3D scanners hardware-wise for the amount of money, especially compared to competitors that are many times more expensive. But they do lack some of the usability, the user friendliness, and the user interface. So I've said it before and I'll say it again, I wish that they would spend more time on the software, making all the icons actually work, making it logical, a good step-by-step guide. I mean, hardware-wise, it's very robust, it's very firm. I'm not afraid of bouncing it, and it's very strong with the motors and all that. But the results they're beyond what I've ever tried before. The level of accuracy that you can get it's just insane. I mean, for example, the Warhammer head, what is that, like a few millimeters wide? And it still captures everything that is less than a millimeter. I mean, I can see the tiny camera thingy lens on his head, and it's less than a millimeter wide, and we'll still have enough data to actually do some useful stuff with it. It's not like 1 pixel. It's a lot of data, and it's really impressive. The paper clips, I mean, come on. You can 3D scan a paper clip. That's super impressive. And speaking of deviation and accuracy, unfortunately, it's not something I can verify or test. On the parts that I've been able to measure with my caliper, my manual caliper, it seems to be spot on. But again, I can't verify it because I don't have the tools to verify it. it looks like it's correct. So yeah, if you're looking to digitalize small objects, mechanical, jewelry, design, product testing, whatever it is, this is a good scanner to do that. Just remember that the volume is very small. There's no way to really be able to scan larger than the volume. Yeah, you have to have another scanner for that. But also be prepared that you have to do some post-processing to really smoothen out some of the, especially if you don't use the scanning spray, you get some noise in some of the models. That's very easy to just smooth out in a post-processing software. Speaking of that, if you want a full guide on like how I post-process a model in ZBrush or Blender or yeah, Mesh Mixer that's free, for example, just let me know and I'll try to get that done as well. As always, my reviews are free, so they have not paid me. This is a loaner unit. I'm not going to keep it. I have to send it back really soon. They're kind of annoying me. So if you want to support my editorial independency, you can always click down below to like donate a beer if you want to. Maybe join up on Patreon. Maybe, you know, maybe buy some stuff via the affiliate links. That's totally up to you. You don't have to, but it would be nice. It helps. And with that said, if there's anything you're wondering about, let me know down in the comments. Check out the links, and I'll see you guys in the next video where we will do some Warhammer 3D scanning. If not the next video, in a video after that. Thank you so much for watching. Have a good one. Bye.